Okay, so let's say as a full example, not just quickly going through grade 9 maths and then saying how it relates, let's do a full example of x minus 2 in absolute values plus 3. So we know that there are two conditions. Either this inside is going to be positive or it's going to be negative. So we can say if what is inside my absolute value is positive, then I know this would just stay as it is. Or if whatever is inside that absolute value is negative, then this would change to negative x minus 2, negative of whatever is inside there. Okay, so then I can go and simplify this a bit further and say negative 2 plus 3 is 1. And I can go and multiply this in and say it's negative x plus 2 plus 3 is plus 5. Okay. If you're unsure of that, do it yourself quickly at the sideline on a piece of paper. I can just simplify my inequality by taking the negative 2 over. It becomes positive 2. And now, again, I have two very simple functions for a line. I have x plus 1, which I should be able to draw, and x plus 5, negative x plus 5, sorry. If I take the negative in, it's negative x plus 2 plus 3 is 5. Hopefully some of you have been screaming at the screen for me missing that. But I have my two lines. I should be able to draw both. Okay, now, both of them are going to meet at 2. So I already know 1, 2. Here's a meeting point that's going to happen. So it's going to be like an axis of symmetry. So it's going to be a reflection over this line, creates the positive slope and the negative slope version. Let's see how that works. So let's draw the positive slope version first. X plus 1 is the graph I want to draw. I can do a table. I can do my y-intercept, x-intercept method, anything I want. So let's try and do according to the intercepts. That would be 1. If I go and scribble on the sideline and say y is x plus 1 is the line I'm trying to draw, what if y was 0? Then x would be negative 1. So it would go from negative 1 to 1. So it would go through there like that. So I can draw my line accurately through there like that. Okay, I drew it in as a dotted line because it's not going to exist over here. It only exists when x is greater than or equal to 2. So I can go up to my graph, and actually if I substitute in the point 2 there, you see it's going to be y value of 3. X value of 2, y value of 3, it's included. So there it would exist, and then I can just say everywhere to the right of 2 this line exists. So that line exists over there. Okay, now let's see the other line. So negative x plus 5. So it's going to be a negative slope. Let's see if I draw that using my x-intercept method. Let's say this is 4, 5 over here. I can say it would have a y-intercept going through there. Where would its x-intercept be? Let's quickly scribble and say if it was a line negative x plus 5 like this, and I solve for x, it would be 5. So 1, 2, 3, 4, 5. So this line would actually go through there and there. So if we follow this, it would look something like this. And then let's see where it actually exists. To the left of 2. If I go and replace 2 in here, I would also get the point 2, 3 like this. It would be an open circle. Doesn't matter, we already have a closed one there. Open circle won't make a difference, and it exists to the left of this point. So I can draw in the line that exists to the left of that point. Okay, with a ruler, obviously. I can't because I only have one hand available. And you can see it goes through that point there. Don't make a big dot like I did. I'm just doing it for explanation. But the point 0, 5 is on there. It doesn't have an x-intercept because it only exists from this point to the right, from this point upwards. We can see the +3 over here had an effect of moving my graph up 3 units. We can see that the -2 over here had the effect of moving the graph 2 units to the right. Okay, I don't need to know that specifically. I could use that info to draw the graph without even doing this calculation, but I can do this or draw a table and just draw my 2 lines as dotted lines and then go and look where they exist and solid lines where it exists to the right of 2, to the left of 2, and there we go. It will always look, if it's a positive value in front here, like a V, and this slope would be the inverse of this slope, so 1 and negative, not inverse, negative of this slope, 1 and -1. If it was 2, it would be 2 and -2. It would be like a reflection over this line of symmetry here. To the right, to the left, a nice V shape. Hopefully this makes sense as an example. Any way you want to draw this line, as long as you only draw it to the right of 2, and this line, as long as you only draw it to the left of 2, they will always meet at the point 2, and we can have a solid dot because one of them is included, and just draw our V shape. That is how an absolute value graph would look.